Welcome back, my fellow programmers. Today on the program, we are going to cover lesson 5.3 documentation with comments. Let's start the program. Our first concept will be comments. Our learning objective: describe the functionality and use of program code through comments. Now, as people, we like to look through our old photographs, we like to read our old diaries, and we like to watch old home movies. All of these things are ways for us to look back in the past and have reminders of things that we have previously done in our life. In our program, we can leave comments in our program. Comments are written descriptions of what code does for human readers. There are two reasons why we write comments. The one is to provide information. That's going to be an explanation about our variables, our methods, our classes, or any of the statements in there. That's so other people who have to read our code will have some idea what the code is doing. It also provides information to ourselves if we revisit code 3 months later, 6 months later, and we try to figure out what we were doing in that code. We can leave little notes for ourselves. The other reason why we write comments is to hide program code, and this is to temporarily remove code for debugging purposes. This aligns with our essential knowledge. Comments are ignored by the compiler and are not executed when the program is run. The first reason why we write comments, we said, is to provide information. If we look at a section of code, now, although this contains code that we might not know and we have never seen before, we can easily read the comments and find out what is going on. So on line 3, we have a comment. It starts with // and it says, "We are opening a file containing Pokemon names." Easy enough. I can just imagine those next two lines have to deal with opening that file. On line 7, we see a comment: create and populate a list of names. Okay, I would trust that lines 8 through 11 are creating and populating a list of names. On line 13, the comment says randomly select and print a name. And on line 17, we have the comment that says close the connection to the file. Comment etiquette says that you should put the comment above the section of code that you are explaining. Also, we don't put a comment for every single line. We just break it up by tasks and we leave a comment for that task. The next reason that we have comments is to hide program code. Here is that same program again, but we have a lot more lines commented out. They're not just the descriptions that are commented out. There are actually lines of code that are commented out. We see that on lines 8 through 11 and also 14 through 15. Well, maybe we don't want to test this right now as we are building the program, but we also don't want to delete it because we might need it later. So we just comment it out temporarily. And all I'm doing right now, I just want to test to see if I can open a file and then close the file correctly. I don't want to have to worry about making the list and picking a random number and printing it out. I just want to test certain functionality, so I'll comment out the rest of it. And that will narrow down if I'm having an error. Well, I know it's in one of the 3 remaining lines of code that are not commented. There are 3 different types of comments that we can create. We can create a single line comment, a block comment, and a JavaDoc comment. We're going to look at all 3 types, starting with the single line comment. The single line comment is a comment that starts at a // and ends at the end of the line. We see that in our code on line 3. This is code for calculating the area of a triangle. So we have a single line comment on line 3. We are leaving the note or the comment that we are declaring and initializing our variables. We can also see single line comments on line 4 and 5. So we have a // everything from that // to the end of the line is a comment. So those are sometimes also known as end of line comments. So these are describing each of the 2 variables. We see a single line comment on line 7 saying that we are calculating the area. And then we see a single line comment on line 10 saying that we are printing the solution. We also see that single line comment at the end of line 11 too. This is a note for ourselves. Should we round this? So this might be a note for when we come back and review this code. Do we want to actually round the area before we print it out? Next up, we have a block comment. A block comment is a comment that starts at a forward slash and a star and ends at a star forward slash. Now, this is to comment out multiple lines of code at one time. So these are for longer notes or to comment out larger code sections. Here you see that I'm leaving a note above the method that explains what this method does. It calculates the area of the triangle, it accepts a width and a height as doubles, and returns the answer as a double. Then you can see I have the method header. I am commenting out a section of code that I would later use for testing purposes, where I would know a given base and a given height. That way I know what answer to expect, but I'm commenting those out because I don't want to use them right now. Single line comment on 12, single line comment on 15. So the difference with the block comment, you have to start it and you also have to finish it. It doesn't just end at the end of the line like a single line comment does. Again, like every other comment, the Java compiler ignores this code. It doesn't even turn it into machine code when we compile it. It just throws away all these comments because these are just notes for people. And when the computer runs it, it doesn't need those notes. Our last type of comment is a Java doc comment. It's a comment that starts with a forward slash star star and ends with a star forward slash. Very similar to the block comment, but it starts with 2 stars where the block comment just had 1 star. Here we see a Java doc comment above a method that we wrote called calculate triangle area. This Java doc comment is formatted in a very specific way because we use a tool called the Java doc tool that will generate our API documentation from these Java doc comments. So there is a tool that will read over these comments and then it will create documentation for us. Taking a closer look at that comment and the format of that comment, we start off with the forward slash star star. That is telling Java that we are starting a Java doc comment. The first part that we have in there is a method description. So we say returns the area of a triangle rounded to 2 decimal places. We have a p tag that is an HTML tag, so we can put HTML formatting in here. And then continuing the description, the height is measured from the tallest point to the floor when one side of the triangle is flat against the floor. Next up, we have some block tags. The block tags start with the @ symbol and a very special keyword. So we have a block tag for @param that describes one of the parameters for this method. We are calling it base, and then we're giving a description of it, the measurement of the floor side of the triangle. We have another @param block tag where we have another variable name height and the description, the measurement from the tallest point to the floor. And then we have another block tag @return in which we specify what will be returned. And it's saying that it's the area rounded to 2 decimal places. Next up, we have the closing of the Java doc comment, that is the star forward slash. And then we follow that by the method header. All of that is going to be read by the Java doc tool. In order to turn this comment into documentation from the command line of our computer, all we have to do is give it the command java doc and give it the name of a Java file to turn into documentation. In this case, all of this would exist in a file called triangle.java. It will go through some steps and it will create a web page for us where it says this is the name of the class triangle. It gives us our constructor summary. It would have our variable summary and our method summary. Here is that method that we wrote, calculate area. It has a base and a height. Here is that description that we wrote. Here is our return type. It's even set up so that when we click on this, it will take us further down the page and have a more detailed explanation of that method in which we see the method header, the description that we wrote, and then those block tags create this formatted area in here. Now, all of this documentation might look familiar. This is what you see when you visit the Java API online because this is how the Java documentation was actually made. Nobody sat down and coded the web pages for the Java API. They just use that Java doc tool to auto generate all of the documentation for all of those classes that we use, like the math class and the system class. When the people originally coded those, they included Java doc comments for all of their methods and constructors and variables. And so then the Java doc tool then created all of the web pages for the API. Our next topic is conditions. Our learning objective: describe the functionality and use of program code through comments. Sometimes before you agree to do something, you have some preconditions. So if somebody asks you to go to the movies, your precondition would be like, well, who's going? Sometimes you have some post conditions. So if someone asks you to go to the movies, you'll say, okay, what time will I be back home? Our methods in Java can also have preconditions and postconditions. A precondition is a condition that must be true before execution of a method for the method to behave as expected. So imagine for a moment that you do not like the square root method in the math class because you don't like typing math.sqrt. You want it to actually be called square root. So you're going to rewrite that square root method and you're going to accept a number to take the square root of. Well, if you're going to take the square root of something, it needs to be greater than or equal to 0. We cannot take the square root of a negative number. So your precondition would be that that radicand needs to be greater than or equal to 0. Otherwise, your method won't work correctly because you cannot take that square root. If we were making a method that did division, one of our preconditions might be that the number that we are dividing by cannot be 0. This aligns with our essential knowledge. A precondition is a condition that must be true just prior to the execution of a section of program code in order for the method to behave as expected. There is no expectation that the method will check to ensure preconditions are satisfied. What that means is just because you put a precondition doesn't mean that that is true. So I could put a precondition that says this method will work great 100% of the time. And just because I put that precondition, that doesn't mean Java is actually going to make that happen. Just because I write radicand needs to be greater than or equal to 0, Java doesn't actually check that. This is just a note to anybody who uses the method to say, hey, if you want this method to work correctly, you better make sure that you give me a radicand that is greater than or equal to 0. When we are answering questions from College Board, College Board will add preconditions to the Java comments for coding questions. You can assume that all input will adhere to this precondition. This is College Board's way of saying, hey, I don't really care if you can check if a number is greater than or equal to 0. What I really care about is, can you write the algorithm to calculate a square root if I give you a number? So it's College Board's way of saying, I'm not actually testing this. You don't need to worry about this. We can also have a post condition, a condition that must be true after execution of a method for the method to behave as expected. Here are a couple of post conditions that you can see. For the first example, this is a constructor. So our post condition might be that all instance variables have been initialized. Remember, we said the point of a constructor is to initialize all of the instance variables to their original state. So the post condition, in order for you to have written this so that this constructor works correctly, all instance variables will need to have been initialized. Another post condition that you will see quite often is that the parameter is unchanged. In that second example, get name is caps, we are passing in a duck, and we want to get that duck's name all in capital letters. Well, since we are passing you an object, you are getting a reference to an actual duck. We don't want you to actually change the name of the duck. We want you to get a copy of the name of the duck and then change that to all capitals. This aligns with our essential knowledge. A post condition is a condition that must always be true after the execution of a section of program code. Post conditions describe the outcome of the execution in terms of what is being returned or the state of an object. College Board will add post conditions to the Java doc comments for coding questions. That's College Board's way of telling you the outcomes that they will be looking for and the outcomes that you will be graded on. That's going to bring us to the end of this lesson. Make sure you rate how you feel about that learning objective. Read over your recap statements. Hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.